A whole class, you've never thought you'd have a whole class about dirt. Dirt. We're going to talk about weathering and the formation of soil. I mean, if you look at that dirt. I love dirt. I love mud. All right? I love playing with mud balls. You can't grow a flower out of a rock. You've got to have dirt, but dirt is a rock. But it's made by the process called weathering. Weathering is a geologic process that happens at the surface of the earth where rocks made somewhere else, deep inside the earth, here's like granite. It's hard. It's hard, okay? But expose it to the surface of the earth. Courtney? Courtney? Damn. I'm going to make it. I can't, it's hard. It's a granite. All right, but expose it to the surface of the earth, and it begins to weather. With oxygen and water, it begins to weather, and these are chemical reactions that start breaking down the minerals in the rock to minerals that are stable to the surface of the earth, including clay and iron oxide. And so here is granite that is weathered. Look at this, watch. Ha ha! Yeah. Look at that, it's weathered. It's weathered. Pretty cool, huh? Yeah, it's weathered. And it's going to clay. All right, and now roots from the plants can get in there and start sucking out the nutrients, potassium and the phosphorus and the nitrogen that they need. Don't you see? Don't you see? And the result, oh, what a mess. It's the formation of soil and rocks and dirt, okay? So, you know, you want to go to school for 4 years, and already I've told you about some great careers that you can have. I've got another great career for you. Soil. Go to school and study soil, dirt. It's lovely. Do you like growing stuff? It comes out. Oh, the whole world is a job that'll never go away now because there's so many of us. Feeding the world. We need better soil, and it takes, don't you see, a long time. Often hundreds of thousands of years, if not hundreds of years, depending on the climate, as you see, to make soil. But if we turn around and blow it away, or erode it away, or contaminate it, then it's gone. Not forever on our time scale. Okay? All right, so feeding the world. All right, here we go. I need this out and this in. Great. All right, from the top, dirt. We love it. Not working. Go. Wait a minute. What's wrong? Get in there. Oh, now you decide to. All right, so soils. Yeah, so you can't grow a flower out of a rock. You've got to have soil. There it is. And not just flowers, but grain, wheat. Oh, look at all that. And so it's a mineral group clay. All right? And they're made in this way. Beautiful chemical reactions that begin to break down the minerals that make up rocks formed deep in the earth, like feldspar and others. And so look at the corn. Oh, a row of corn, and here beautiful Indian paintbrushes and blue bonnets and cactuses and trees and more flowers. All right? Clays. It's not just about crops. Clays. You can do so much with them, and we'll review some of that. They're used for making oil absorbents, iron castings, animal feeds. Yeah, dog food has got some clay in it. Pottery, your china, pharmaceuticals. That stuff you smear on your face this morning had clay in it. All right? If you had a little upset stomach, you might have taken kale pectate, got clay in it. What do you think stops you up? Clay. So there's so many different uses, even cat litter. All right? So here we are. Lime. We use it to drill for oil. Oil. The world needs more and more oil. Maybe we should walk away, but how do we get it out of the earth? Well, we drill for it. And yet, the way we do it is we use mud made out of clay, drilling mud. And it lubricates the drill and cools the drill and helps prevent gushers from happening. All right? Gushers. Because the drilling mud is made heavy with minerals in it It helps contain the oil. The oil down there is under great pressure, and it wants to gush up once you drill into it. So it's many different uses. Great, great stuff. All right? So we use it for filtering. Look, here's some nice olive oil. We use clays to help filter that. Those of you who like to play golf, forward. Stay out of those water traps. Oh, I have played golf sometimes. I'm pretty dangerous with it. I like to play mostly on everybody else's fairway but the one I'm supposed to be on. And my golf balls are like a magnet for water. But, all right, how come that water just doesn't sink into the ground? They line it with clay. So the water doesn't sink away, all right? So it's all there. Clay, so many different uses, not just flowers. It just begins there. All right? Go. Other things, you can make pipes out of it and smoke illegal or legal stuff. Clay pots, ceramic vases, early marbles. Yeah, they're all there. And cat litter. You know, cats have been around. Age of mammals that we're in and domesticated for a long, long time. And even back thousands of years ago, we had kitty cats, kitty cats, kitty. And they knew that little kitty would go potty pop poop in a box of something. All right, and early on they would put sand, go a sandbox, all right? Or they use ashes from the fireplace, all right? But then somebody discovered clay, particularly a particular kind of clay called swelling clay or Montmorillonite. And a whole new industry was made. Here, kitty. Because the little cat goes in there and does its thing and buries it, and then the clay particles swell up around the liquid, and they clump around, they clump it, all right? Good clumpable stuff. Oh boy, it's an industry. The best dirt, however, is not pure clay. The best dirt is actually a mixture of clay, finer silt, and sand. Right there in the middle, we call that loam, 1/3, because the quartz, the sand, helps air get in there. What do plants need that comes out of air? What is the most abundant element in air? Hydrogen? Nitrogen! Way to go, nitrogen, okay? Yeah, lots of nitrogen. But how does it get in there if you don't have grains of sand to help keep it open to the air? So that's a good mixture is like that. So grains of sand, you go with all clay, it just clouds it. But soils take a long time to form, and you let it blow away like the Dust Bowl. That's a big issue. Even today, erosion of our farms, as we grow things here, there was a Dust Bowl, all blew away. And so today, practices, we're learning more and more about how to have good practices. We're training farmers all over the world. You want to be part of this? Good practices. One thing we've learned to do is when we plow, is to prevent dust. We've learned to prevent dust blowing away. We've learned to leave some stubble out in the field. It's called no-till. For years, when people farmed, they would plow the fields, they would grow the crops, they would harvest the crops, and then at the end of the growing season, they would till the land, turn it back over again, and turning the old dead crops back into the soil with the idea that it would biologically decay. Ellie? Got one right. All right. I'm getting better. But we've learned to leave the stubble. No-till. Don't till it. No-till, Sean. No-till. All right? And leave the stubble there. It's good for wildlife, and it helps keep the soil in place from blowing away. So here's a tractor going through, but it's harvested now, but it's not going to till. So the weathering that I'm talking about, I've described the chemical weathering, but it starts first with the rocks just getting cracked. And that's called mechanical weathering. That's the first part, mechanical weathering. And look at these mountainsides. Look at that. From Yosemite up into the high Cascades. I took this picture with those cows, quite excited that I did, coming down from the state of Washington. I looked at those rocks off to the side. I threw the brakes on my truck. I got out and I said, look at that. And the cows were going, yeah, look at me. But I was texting, but I really didn't want to talk to the cows. I was looking at the cracks. These cracks are called joints. Now you think joints are something you smoke illegally. No. You might. But this is a different kind of joint. It's a crack, and it's the first step of weathering, the mechanical weathering. The mechanical weathering, this is a very famous pulpit in Norway. And look at that crack. You can't smoke that kind of joint, but there it is. And somewhere here, somebody's completely naked. So before you can find it, I'll move on. So joints are made in different ways. They can be made by pressures on the rock. If it keeps enough pressure, it'll actually crack and slip, and that's a fault. But if they don't slip, it's just a joint. They can be caused not just by pressure, but also by expansion. As the rocks get to the surface of the earth by uplift and erosion of everything above, then all of a sudden the pressure, well, what was above them is off. And the rocks actually expand as they come to the surface of the earth. And that expansion causes an unlayering. Foliation is layering. Here is exfoliate. It's unlayering. Some of you like to exfoliate your skin. Oh, it's hurtful. And here are rocks that are exfoliating their skin. The exfoliation joints. Joints created by expansion. All right? Look at those. Look at that. And they got trees. I said a tree can't grow out of a rock. It can once it starts weathering. And so I've got mechanical weathering here, a crack. And in those cracks, chemical weathering has made just enough dirt so that the plants, the trees have roots, can penetrate in. All right? Look at that. Exfoliation. Here's Half Dome in Yosemite. Look at the exfoliation joints. Here's a close-up view with trees growing and moss. Look at those cracks. Parallel to the surface of the land, about to fall off right there. All right, I took that picture. And they're also made not just by expansion, but by contraction during cooling of volcanic rock. And here are volcanic rocks cooling. Hey, look out. Would you do that? Could you? These are called columnar joints because they make columns. All right? So they make these six-sided shapes, columnar joints. So joints are the first step of weathering. It is mechanical weathering. And that exposes the rock to air and water, and then the chemical weathering body. The chemical weathering. You're not on Facebook, are you? Oh, no, sir, I would never do that in your class. Sarah? No. And so the rocks crack. Now, we've already talked about frost wedging, but that has a role here. The water goes down, it expands, and it starts falling. We talked about talus. And so that's mechanical weathering, starting the process. And then we talked about not putting a home there, all right? So mechanical weathering triggers the first formation of landslides and airfalls. And then it's a chemical weather. Oh, that's not me. All right. My computer was getting mad. So as the rocks weather, chemistry starts happening. All right? And if the rocks have sulfide minerals in them, such as fool's gold, we call pyrite. A lot of rocks do. Fool's gold, ore minerals, a lot of ore. All right? We love metals, and a lot of metals come from sulfide minerals. Those sulfide minerals are stable inside the earth. But you expose them by nature or unnaturally. Look at that mine. They start oxidizing to rust, red water, and releasing the sulfur to make sulfuric acid. And it's deadly stuff, all right? So this is known as acid mine leakage, and in this case it's unnatural, but it's weathering, chemical weathering. All right, chemical weathering. Look at that red stuff coming out. And here is a huge copper pit. We like copper. Can't have a wire without copper. It's huge. It's a big hole. I mean, look at these. These are trains. Look at that train. Look at that train. These things are big. Well, I like this view because you can look at this zone of brown, right? And that just shows how far down oxidation, browning, weathering of sulfide minerals making rust, a mineral called hematite. All right, so there it is, zone of weathering deep inside the earth, weathering as you go. Many rocks. Choose your tombstone. All right, someday you're living, you're wonderful, you're alive, but someday you're going to die. How are you going to die? I don't know. Well, what would you like in your place? Well, some of you might want a tombstone, and invariably it's going to be made out of a rock. All right, then come with me. Let's go to the old graveyard of Boston and look at the old grave. I love doing this. All right? I do. I really do. And I go around and I look at all the names, but I'm also looking at the tombstones, how weathered some are, and how some are not. Some of them, they read perfectly like they were made yesterday, but others, they're so dissolved away, weathered away. You can hardly read them, right? You seen that? It's kind of wild. How old was that? If a baby died, you see? All depends on what the rock is made out of. If it's made out of marble, and a lot of people chose marble for their gravestones because it's easy to carve, it dissolves. Because rain is naturally what? Acidic. And then of course now we have acid rain where it's worse. It's dissolving away. Well, here is, look at this. This is marble, metamorphosed limestone. It's on the coast of Maine, and it is weathering away. Look how sharp it is. I can tell limestone or marble blind by touching it because it is sharp. Here with a knife or scale, it's sharp because it gets pitted by rain. Rain is naturally acidic and dissolving. You take acid, drop acid on limestone, the mineral calcite, it bubbles out carbon dioxide. Bubble. And so it's weathering away. All right, weathering away. Here is 1970, fairly new gravestone. I took that picture and this one. 1870, almost gone. All right, choose your tombstone. Well, the worst one you might choose is marble because it dissolves. Okay, it dissolves away, particularly in wet environments. Now, in dry environments, like Arizona, it lasts a long time. Wet over here in this part of the world, granite lasts longer. All right, weathering does happen on granite. I just showed you some granite, but it takes thousands of years to weather granite. Again, it really depends on the climate. Here is out by Zion, Utah, near Zion, near the town of Zion, near the national park. This was a cemetery that got flooded, and mud covered the tombstones for 100 years or so. Now excavated, all right, archaeologically, people came in, excavated it out, but look where it's set in mud. Mud, water is a catalyst for chemical reactions. So we're talking about weathering, all right, covered with mud, and it weathered away. And yet here in that same graveyard, but outside the flooded region, made out of wood. And this was John William York, born January 1853, and died just as a young teenager, 1866. I look at these and I imagine, what happened? What was the story? You know, you don't always know. Here is a granite obelisk, two of them that are from Egypt. This one fell over in the Nile and was buried for a long time, and you can see with water there, it was eroding, weathering away, but this one did not. It was not buried in mud, and it's just like perfectly made. So water is a catalyst. Catalysts are entities that speed up reactions, in this case chemical weathering. And what does it make? It makes clay. All right, so here I hold in front of you good old clay. All right, sometimes white, sometimes brown. This is pure clay, and it's made from weathering. You take feldspar. That is 2/3 of what a granite is feldspar, white or pink. It weathers away. Silicon and potassium, the sodium get dissolved away. It leaves the rock richer in aluminum and sometimes iron. And that's what clay is, rich in aluminum. If it goes all the way and keeps weathering, you make aluminum ore. All right, so this is how aluminum ore, this is what is a future beer can. This is bauxite, aluminum ore. All right? It's great stuff. Doesn't look like a beer can, but this is the richest aluminum ore in the world. And if you get aluminum hydroxide, all right? There's other aluminum minerals out there, but nothing as rich as bauxite. That's how bauxite is made. It's made from weathering, all right? So there we go. Clay minerals. So I was talking about kaolinite. It's the purest. It's used largely for making china and porcelain. Illite is another one. It's really common in soil. But the dangerous ones are the good ones, depending on your industry, are the swelling clays, smectite or montmorillonites. This is what cat litter is made out of. So if you want to get into the industry of cat litter, you've got to go look for the swelling types of clays, all right? And we can actually map those swelling clays. They pick up their volume with a little kitty, 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 goes pee, pee, and poo, poo. It clumps. It's because it's swelling clay. It is wonderful. Actually, the world has been mapped. You can go to the U.S. Geological Survey, and they have maps of where the red is. This is areas that have swelling clay. Look at New Orleans. All right, a lot of it there. Okay, so swelling clays. the rates of weathering depends on what the rocks are made out of. Choose your tombstone. I've told you about marble, dissolves. Volcanic tuff weathers very quickly. Anything made out of glass weathers very quickly, so that would be the worst. In general, igneous rocks are the really high temperature rocks, so they tend to weather faster. Lower temperature rocks like metamorphic weather slower. Okay, that's why slate, all right, blackboard slate's a metamorphic rock at a low temperature one. And it weathers really slowly because it was made at a lower temperature. It's not as unstable as the surface of the earth. So the tombstones in Boston, a lot of slate roofs. Last a long time, okay? All right? And then coming on down, other metamorphic rocks, serpentinite, quartzite, all would make excellent tombstones, all right? So here is a granite. I took this picture with what we call a dike going through, but look at the joints. Look at the cracks, and it's weathering. Well, this is the outcrop where this rock came from California, and someday I'm going to run out of it, or I have to go back. Or find a new place here, okay? And I will. And it's falling away there with my good dog Nugget for scale. It's so soft that lizards can dig holes in it. So it's weathering away. So granite, the weathered granite has a name. It's called gruss, and that chemical weathering is the first process in the formation of sand and clay. Okay? Sand and clay. And eventually, as I mentioned, extreme weathering, see there Zach, he's got an interview. He's going to get a job. He's going to graduate. I've got to graduate? I mean, I just can't come into geology classes? That's right, you got to graduate. And so, with chemical weathering, a lot of the elements that are there, silicon, and sodium, and potassium, are dissolved away, leaving behind, causing enrichment in what's left. Aluminum, some iron. And so here is what bauxite looks like. Bauxite, a good old aluminum ore. It doesn't look like a beer can, but that is rich in aluminum. So weathering proceeds along cracks and causes these really interesting spheroids called spheroidal weathering. Sometimes the clay blows away, leaving behind just boulders. All right, this is this environment created by weathering. All right, there's dog Nugget sleeping on a boulder created by weathering. Doggy, hey Nuggy, love you. And so here we're looking at weathering proceeds along cracks, but then it's going to move in from the cracks. So you start with a cube, and it starts moving in, and eventually you get a spheroid between the cracks. So this is called spheroidal weathering. Look at that. Look at that. Look at that. Look at this guy. That's me. Like 1977. I told you I'm 149 years old. So these boulders, you know, how do they get there? They're weathering out. They're weathering. The landscape formed by weathering along the cracks, proceeds inward. So what affects weathering? Well, a lot of different things. We've talked about what the apparent material is made out of, how much relief is there, it's how steep. Look at that land being weathered, all right? The climate's really important, wet versus dry. Organic activity, we need the worms. And then time. I mean, if you're on the East Coast, you can get an inch of soil in some places in about 10 years. But in most places, you need several hundred or several thousand years to make any kind of zone of soil, all right? But worms help. Worms help turn over things. I'm really good at dirt. I love dirt. I love to see worms. Look at that. They get in there, they help turn the soil and get the nutrients turned around. Basically, soil comes in two ways. We can transport it with wind and water. And so here is where a stream has come in and formed a lake. Look at all the mud. That's transported. Or we make it in place. And that's residual soil. And we have just three kinds for you to know about. Petticow soil, where it's fairly dry. It's rich in calcite. That's why it's called petticow. Other soil minerals. It's not a very nutritious soil. In the East Coast, we have a lot of Pedalfer soil. So here in Boston, Pedalfer soil is what you've got. It's because of high rain. It's richer in aluminum because there's more weathering. Richer in iron. The most extreme of that environment, where it's really wet, we get a red soil called a laterite. And then it's got too much aluminum and too much iron. It's only good for growing jungle plants, all right, and marijuana. But otherwise, it's good for making baseball diamonds and bricks. It's too rich. But, you know, the soils of Hawaii, Puerto Rico, Dominican Republic, they're red, all right? So those are laterite soils. But Balfour is the best, good black soil, just perfect. So weathering starts along cracks, and then weather starts, and then it rounds the corners, making spheroids, all right? And gradually residual soils form in place, okay? At the very top, we have the O horizon, which is rich in organic matter. The A horizon is the richest. The B horizon is got some residual material in it. And then the C horizon has got quite a bit of residual. So these are the three different main A, B, and C, the three soil zones. They're all there. But where the rocks are dry and the weather is dry, you don't get a very thick soil. So here's a soil horizon. It's really thin, okay? Really thin. In contrast, we go to Hawaii. You can see the different soil zones, but they're quite thick. And it's red. That's lateritic. North Dakota. I took that picture just to take a picture of the soil horizon. There's the soil. These are rocks, and they're weathering, but there's the soil. All right, not much there. Good for ranch land. Good for cattle, but can't grow corn there. All right. So we're learning a lot about soils. The whole field of conservation has spawned, preventing our soils from getting harmed. One way they get harmed is the buildup of salts. When you irrigate, water has salts in it, a natural hardness. And you irrigate, and part of it dries. You irrigate some more, part of it dries, leaving behind salts. Okay? You irrigate, part of it evaporates, leaving behind salts. That's called salination. And the first place where salination was documented and written about was in the cradle of civilization in Iraq, what we call Iraq today, the Euphrates Valley. The good records of growing corn and wheat, and over years, the kings, kept a record. After a while, they could only grow hay because the soil was ruined by irrigation. The way you prevent that is you have to irrigate a lot. So you flush the salts that you leave behind out of the soil. Soil erosion, we've learned to put up tree breaks. We've learned to contour the plow. Here we're plowing, and we follow the contours of the land to help erosion. So that water wants to run downhill. So you don't plow that way. You plow along the contours of elevation, preventing water from moving down. Okay? So that's called contour plowing. We talked about no-till. All right? Also, nutrient depletion. You can't grow the same crop in the same field year after year. Farmers know this. They grow corn in one field. The next year they try to grow corn again. The corn is going to come up spindly, weak. So they need to grow something else, like wheat. So they rotate, a crop rotation. Otherwise you deplete it, and then you're left with large expenses of having to fertilize a lot. So instead, they don't want to do that. They just rotate, change crops. And then contamination. Herbicides and insecticides, such as DDT. We've learned to use less of that. Use stuff that breaks down by biodegradation. Organic farming is really good. All right. So it's all there. Whoa! Wait. Try that again. Maybe. Try it again. All right. Oh, there we go. I can't hear him.
Strategy to kill the weeds. And now we have better ways and means to kill the weeds.
So all over the world, we're learning industry of how to grow things organically, how to practice no-till, how to use less and less chemicals. This could be you.
And this is very beneficial for the environment.
So farmers are right out there, feeding the world, but also they've learned to be environmentalists, trying to save their soil, save their land.
Erosion was very serious, and it was very damaging to the environment, to the extent that in these crops, to produce 1 ton of grain in Brazil, we lost 10 tons of soil per hectare per year. We solved this problem by eliminating tillage. With no-till.
No till. Till's when we plow it back into the ground. We learn not to till, so it's called no-till. Leave the stubble there. It gives a place for the pheasants and any other wildlife to live and
We don't
thrive.
need to burn the crop residue, and we don't plow.
We don't plow.
When we changed from conventional planting to no-till, it was only possible because of an herbicide product with total action. We could get a soil which was tolerant to
Look at all that. Love farming. I could have been a farmer. All right. So there you have it. Now, on the other end, soils get contaminated, and this is a whole new industry. Learning how to get the contaminants out. It might have been an accident, or it might have been on purpose. And four big ways we do it. One is dilution. You take good, clean soil, kind of dilute it in, but that's not very effective. But the others are really interesting. Here we're using bacteria and fungi to help break down. You can break down petroleum, all right? Break down. We also can pass air through it to help chemically get rid of it. Or we grow plants. Here they're growing plants. Phytoremediation grow plants that extract the contaminants. So this is also a whole new industry as well. Now I want to take you on a geology tour, emphasizing weathering. You like landscapes. I'm going to make you dangerous on the highway, driving through beautiful areas. You'll look back and you say, oh yeah, Dr. A showed us that. So, geology vista. Let's go. Weathering proceeds along bedding planes and along joints, making these columns. It's created by weathering, don't you see? And where the rocks are softer, the weathering goes faster, creating this overhang where early peoples could live, created by weathering. All right? Bryce Canyon, look at that landscape. Now you know what made it. Weathering. Weathering along bedding planes, weathering along joints combined to make these unusual, wonderful features. Look at that pedestal. And now you know what made it. What? Weathering. Yeah, weathering. Mechanical, where first we make the joint. Look at the joints! Can't smoke now. And the bedding planes, they intersect and you make wonderful columns out there. Petrified wood sitting on top of a layer of sediment, isolated by weathering. It's great stuff. And you get these, well, they're called hoodoos. These columns are called hoodoos. Go to Wikipedia. The goal of a hoodoo is to allow people to access supernatural forces to improve their daily lives by gaining power in many areas of life, including gambling, love, divination, cursing one's enemies, and treatment of disease. So they think. But regardless what's true or not of what I just said, these are called hoodoos. People think they have special powers. What made it? Yeah, weathering, yeah. I mean, this is a funny one. The most famous photograph hoodoo from Carmel, California. Why do you think people are inspired by that rock? Yeah, it looks like one, don't you think? Yeah, you can go get this off of the black. Yeah, she's wrinkling her face and he showed a picture that looked like a penis. Well, yeah. But there's other farms and they create arches. All right, look at that natural arch, natural bridge. Oh, yeah, created by weathering. Weathering along cracks, bedding planes, all shaping the land. Oh, look at that. It's great stuff. Here is Shiprock, New Mexico. It's a volcanic neck. The volcano is weathered away, but where the igneous rock is, in the neck of the volcano or along a dike, it weathers more slowly. And so it hits dike like the dikes of Holland. They get their name from standing walls. It's called a dike. All right? Weathers more slowly, stands out from the ground. Beautiful. Monument Valley. Good for Jeep commercials. Or how about that one with that gal climbing? Don't you just stop and when she gets on top of that pedestal? You've seen that one? Yeah, would you do that? There's no effing way I would do that. I stop and get a little bit scared every time I watch that commercial. And it's real, right? Yeah, it's real. Wow. Wow. And what made that pedestal? Weather. You got it now. Look at Monument Valley. Oh, it's there. From our gravestones, born 1841, killed by Indians. Oh, I'm sorry, Robert. Oh, just a mere 25 years old. Hope you got some of them. So I took this picture. This, you like mustard on your hamburgers and hot dogs? Yeah. Well, where does it come from? Mustard. Mustard, silly. This is in Sweden. I was there for a conference, and I was out running in the country, and I came upon this beautiful field of yellow. It's mustard. Went back to my hotel, got that camera, came back just to show it to you. Look at the yellow. We grow crops out of it. We feed the world out of it. All right, but it blows away. This world, our earth, has given us a place to live, to build our cabins, to raise our families, our growing population. It's a wonderful place that we have. But with all the life forms on our planet, realize that our earth now knows you're here. And we're affecting this planet. And we're running out of ways to feed the world. And we need a whole new industry out there. So I have jobs for you. But it's not just about us. It's also about all of them. All right? Because they can't do anything about global climate change and soil erosion and pollution. It's up to us. I do have a job for you. Have a good day. Oh, I got done.